In the summer of 1985, a magnitude 7.3 earthquake shook the eastern shores of New Zealand's North Island, creating a fissure in the ocean floor some 175 miles away. The rumbling of this so-called remotely located earthquake revealed something strange: an enormous underwater mountain rising over 10,000 feet from the ocean floor. Geologists were surprised to find that this seamount was actually the top of a massive shield volcano larger than any previously discovered in the region. And unlike its sister volcanoes on land, it had flown under the radar, hidden beneath thousands of feet of water for thousands of years. What's even weirder is that scientists think there could be as many as 100 similar volcanoes just waiting to erupt off the coast of the United States. So here's the deal. Shield volcanoes are known for being really big, but also kind of lazy. Unlike their steeper cousins, stratovolcanoes, which are prone to explosive eruptions, shield volcanoes tend to pile up material slowly over vast stretches of time. As lava oozes out of them, it quickly cools and solidifies into jagged basaltic rocks that spread out into the surrounding ocean. Eventually, these rocks build up enough mass to poke their peaks above the waves, creating islands. You may have heard of some famous examples like Hawaii's Big Island or the island of Madagascar off the coast of Africa. But what happens when one of these oceanic volcanoes gets too big for its britches, but not big enough to breach the surface? Enter deep ocean guyots. A guyot is basically a submerged mountain peak that starts out as an oceanic volcano. These mountains can reach heights of 10,000 feet or more, but because they're buried under so much water, erosion takes a heavy toll on their shape. Over time, the weight of the water causes the peak to flatten, turning it into a truncated pyramid or a plateau. It's like someone took the top off a bottle of soda pop. That's where the name Guyot comes from. It's French for short or stubby. Now, most of these submerged structures aren't technically volcanoes anymore, but they do start out as volcanic mountains, and they often still have the flat tops characteristic of shield volcanoes. Plus, they sometimes show signs of recent volcanic activity, which is why scientists categorize them as submarine volcanoes. Scientists use sonar to map out guyots on the ocean floor and satellites to measure changes in the Earth's gravitational field. Each one is unique, and some are even home to entire ecosystems, but they've remained largely unknown until recently due to the difficulty of exploring such deep waters. In fact, the first Guyot ever discovered wasn't actually discovered at all. It just kinda appeared on sonar maps of the Indian Ocean published in the 1950s. When researchers dove to the bottom to check it out, they found coral reefs, sponges, seamounts, and guys. They're related but not identical. Seamounts are individual volcanic peaks, whereas guyots are usually groups of closely spaced peaks. To qualify as a seamount, the peak needs to rise at least 1,000 feet from the sea floor around it. Just like with guys, seamounts can have flat tops too, but they don't have to. Some look like pointy shark teeth, while others resemble flat saucers. The tallest seamounts are over 3,000 meters high. Some researchers estimate that there are as many as 100,000 seamounts scattered across the globe, though we've only explored about 1%. Although seamounts and guyots form in a similar way to their fully emerged counterparts, they don't get quite as tall. That's because the immense pressure of the water column above them compresses the rock, making it harder for gas bubbles to form and escape. Without those bubbles, the lava can't pile up into tall, steep piles. Instead, it spreads out as flat, sluggish flows. And when the lava hits the cold ocean water, it hardens quickly, cooling into a dense, heavy rock called basalt. This means that seamounts and guyots are mostly made of mafic igneous rock, whereas the lavas that pile up on land tend to be more felsic. And although we tend to think of volcanoes as towering cones, many of the ones we know and love are actually shield volcanoes in disguise. Mount Kilimanjaro in Tanzania, for example, was once a towering stratovolcano, but now its gentle slopes are all that remain. Similarly, the island of Hawaii is home to Mauna Kea, whose height, when measured from its base on the ocean floor, would make it taller than Mount Everest. It's just that most of the mountain is submerged. Same goes for the submerged portions of seamounts and guyots. For instance, if measured from their bases on the ocean floor, the tallest seamounts would rival Everest, and some would even surpass it. Guys are interesting, not just because they're flat, but because they're also big. In fact, some of the largest seamount chains on the planet are actually submerged guyots. Take the Shatsky Rise, a vast pile of igneous rock in the western Pacific Ocean that rises 2.5 kilometers from the surrounding seafloor. The Shatsky Rise is so big that it's been dubbed the eighth wonder of the world. Although it hasn't officially been dated, scientists think it's around 140 million years old, which makes it nearly twice as old as the Himalayas. Another giant guyot named the Tamu Massif in the northwest Pacific was once thought to be the biggest of its kind. At 120,000 square kilometers, it's almost the size of the state of Montana. But more recent research suggests that it's actually two separate features that collided with each other long ago. The sheer size of these features has left scientists scratching their heads, especially since they tend to punch well above their weight when it comes to triggering earthquakes. On April 2012, a magnitude 8.2 earthquake struck off the coast of Japan. Surprisingly, the epicenter was over 300 kilometers from the nearest city. Even more surprising was the fact that the quake had a hypocenter, or depth, of nearly 80 kilometers. That's deeper than 99% of earthquakes recorded by humans. And the culprit was probably a seamount named Meiji Seamount. The area around the seamount was swarming with seismic activity for days before the main event. And according to one researcher, the fact that the waves from the earthquake radiated outward in all directions suggested that the source of the quake was unusually big. "We don't know exactly how big," he said, "because we haven't drilled into it to see." For a long time, geologists debated whether seamounts like Meiji were the sites of ancient, long-dormant volcanoes. But nowadays they're generally considered to be active. In fact, seamounts are home to some of the youngest igneous rock on Earth. By measuring the magnetic properties of the rocks, scientists can determine when they were formed. And in some cases, the numbers are surprisingly recent. One team estimated that pillow lavas on the Clipperton Guyot erupted just 35,000 years ago, while nearby seamounts like Wheeler and Pioneer were only 27,000 years old. According to geochemist John Bacon, the youngest samples of oceanic crust currently known come from the axial seamount. It's a seamount in the North Pacific that has been erupting continuously for the past 23,000 years, but no one noticed, because it's, underwater. And yet, despite all the evidence pointing to their activity, many seamounts and guyots remain mysterious. It's difficult to study them after all. But thanks to new technologies, scientists are finally getting a closer look. Using remotely operated vehicles equipped with cameras and drilling equipment, researchers are able to venture down thousands of feet to collect samples and survey the terrain. In July of 2022, a team from the Scripps Institution of Oceanography in San Diego deployed a remotely operated vehicle named Siren to explore the rarely visited Meteor Seamount. During their dive, the team discovered signs of life at depths of over 4,000 meters, including small crabs near the summit and shrimp and anemones near the base. So yeah, seamounts and guyots might not be the most well-known volcanic structures on the planet, but they're certainly some of the most intriguing. They're home to unique ecosystems prone to sudden, powerful earthquakes and potentially capable of causing major eruptions. Not to mention, they're just plain weird. So next time you hear about a volcano that erupts underwater, ask yourself, is it a seamount or is it a guyot? Because in the end, they might just be the next Yellowstone. Thanks for watching this episode. If you want to help us make more videos like this one, head over to our support page.